Welcome to Mechanical Engineering 2240, Mechanics and Materials at Dunway College of Technology. I'll be working through a quick example on principal stresses and state of stress, max in-plane shear, etc. from Hibbeler. This is example F94. So we're given this state of stress here. We have, and we're asked to find the max in-plane shear stress at this given point. So we look through, this is in section 9.3 on principal stress and max in-plane shear. So as we look at this, we've got sigma x, 100 kilopascals, sigma y, 700 kPa, and tau xy, this bit here, is negative 400 kPa. So we look back in our formula. We find that tau max in plane is given by the square root of sigma x minus sigma y over 2 squared plus tau xy squared. So we can just plug these guys right in here and that one over there. So we find that we have the square root of 100 minus 700 over 2 squared plus negative 400 squared. Plugging those in, we get 300 squared, negative 300 squared, excuse me, plus negative 400 squared. So we get, it's going to be 900,000, 1,600,000, actually, plugging that in, we get 500 kPa as our tau max in plane. And our average stress, let's see, I don't think it asked us for the average stress, but that's what we'll have acting on this. Remember, when we have the max in plane shear, we still have the average stress acting on the other sides. This is going to be sigma x plus sigma y over 2. In this case, we have 100 plus 700 for 2, 400 kPa. And we may want, we weren't asked to do it, but we may want to know what the orientation is for that element, right? So if we had our original element, now we're going to have some rotated element. We have some rotated element that's theta s away from our original element, where we'll have our max in plane tau max. I drew it negative here, and then we'll have sigma average in these other directions. Alright, so what is that arrangement going to be? So we may want to find that. We are told, we derived in the section tan of 2 theta s for our shear stress is going to be negative sigma x minus sigma y over 2 over tau xy. So what do we get there? We have negative, this is 100 minus 700 over 2 over negative 400. So we have, as I work out to be a negative 600 divided by 2 is negative 300. So we get negative 300 here times a negative is positive 300 over 400. I pulled the negative from the 400 up to the top, and so we get tan of 2 theta s is negative 3/4. Solve that, theta s was negative 18.43 degrees. So we'd actually be rotating the other direction, or plus 90 from this would get us that that orientation where we have the max in plane shear and our average stress acting on our element.